So it is not 1K, it is 3K. So when 30K, the current through the GNA diode is 9 milliamps. When 10K, it is 7 milliamps. When 3K, current through GNA diode IZ equal to 10 minus 10, 0 milliamps. 0 milliamps. So it will not work as a, so it will come out from voltage regulator. Since no current is produced, no current flowing through it, is come out from voltage regulator. So the load resistance is very important. You cannot give as many load as possible. So there is a limit in the load resistance. So you can give up to 10 kilo, 8 kilo ohm. So after that you cannot give it will increase the load. So if you give 10 kilo ohm, it is working properly. If you are reducing the load to 3 kilo ohm, so now the diode won't work. So it comes from the voltage regulator. So whenever you are using a GNA diode as a voltage regulator, so the load should be connected in parallel, and the load should be have some resistance. So a particular amount of resistance it should have. If it is less than the amount, it will not work. GNA diode comes from the voltage regulator, so it will be cut off. So remaining circuit works as a actual circuit. There is no voltage regulation. Write it down. We go to the next topic. So these are the problems in GNA diode. One more problem is there in transistors. So write it down. It's simple 2 more question in transistors. Rubbing the right hand side. So here, so you have to find beta and gamma. Beta and gamma. If alpha is equal to say 0.8. So first write down the equation. Beta equal to alpha by 1 minus alpha. Gamma equal to 1 by 1 minus alpha. So alpha is 0.8, 1 minus 0.8. So 0.8 by 0.2 is equal to 4. So here 1 by 0.2. So actually 1 minus 0.8. So 1 by 0.2 is equal to 1 by 0.2 is 5, I think 5. So it is a 2 mark question. So you should know the relation between these. Sometimes they will give gamma. So this is a tricky question. This one question. Another one, they will give the question of, they give a gamma equal to 0.5. You have to find beta. Gamma is 0.5. You have to find beta. How you can find? You know gamma equal to 0.5, but you have to find beta. First you have to find alpha, then only you can find beta. So gamma is 0.5. So here 1 by 1 minus alpha. Alpha it doesn't know. So it can be written as 0.5 minus 0.5 alpha is equal to 1. So 0.5 alpha equal to 1 minus 0.5, 0.5. So alpha equal to minus 0.1. So alpha equal to minus 0.1. 0.5 into minus 0.5 alpha is equal to 1. So I'm moving 0.5 that side. So 1 minus 0.5, it is 0.5. So alpha equal to minus 1. Sorry, alpha equal to 0.5 be fine by alpha equal to minus 1. Now you have to find beta. So beta equal to minus 1 divided by 1 minus minus 1 minus 1 by beta equal to minus 0.5. This type of question may be asked. They will give gamma and they ask beta. There is no direct relationship between beta and gamma. So you have to first find alpha, let's find beta. Otherwise, they will give beta and find gamma. They will also like that. So you have to first find alpha and then find the gamma. It is somewhat difficult because there are two alphas. Here only one alpha. Then there are two alphas. There will be an equation. Let us solve this. So this is somewhat easy when compared to when beta given and gamma find out. So question may be asked like this in 2 mark questions. You should know these two formulas. So if we finished, we will go to the next topic. So these are the problems in electronics. So in electrical, you have a lot of problems. In electronics, you have this much problems only. So G-N diode has voltage regulator, this alpha, beta, gamma, and rectifier problems. Two type of rectifiers we have seen, half-wave and full wave. So very limited problems in electronics. So if we go for electrical, there are a lot of problems. So if you put, if you have completed everything, put completed, so that we can move to the next topic. Okay, so these are the problems. We see to the next model. So before going to the next model, I will ask some questions. How far you have studied in machines so far? How you are understanding the subject? How you are listening to the class? Tell me what is lacking. So I will point out on a task, then only the answer will come. Dayanand, morning absent. Now I present or not? Dayanand.
சார் இப்போ ரெஸ்பாண்ட் பண்ண மாட்டேங்கிறான்.
இப்பயும் ரெஸ்பாண்ட் பண்றது இல்லை. அவர் எதுக்கு போன் ஆன் பண்ணிக்கிறான்? யாருக்கு கிளாஸ் எடுக்கிறான்னு தெரியல. கௌதம்.
சார்,
வாட் இஸ் பேக்கிங்?
sir, it is used to store electrical energy, sir.
இல்ல ஜெனரேட்டர்ல வந்து ஜெனரேட்டட் இஎம்எஃப் இஜி. So what is back EMF? My question you have to understand what is back. So in what machine back EMF is generated? If you doesn't know, you tell I doesn't know. No problem.
It doesn't know, sir.
Okay, thank you. So what is back EMF means? So in a motor we are giving a DC supply. Okay. So electrical input is given. So it is converted into mechanical input. Okay. So the mechanical input, mechanical energy is produced in the motor. Okay. So the equivalent electrical energy of mechanical energy is called back EMF. So if you are asked what is back EMF in DC motors, you have to tell it is the equivalent electrical energy of mechanical energy produced in DC motors. Okay. So next one, ask some other. Ivan Joseph. Why transformers are rated in kVA?
Sir?
Why transformers are rated in kVA?
Sir, I can get your question. Could you read one more?
Why? Yes, I put in the chat box.
Thank you, sir.
So if you buy a transformer, they will ask what is the rating. So they will give the rating in kVA, kilovolt ampere. Kilovolt ampere. Kilovolt ampere, kVA. Why they are mentioning in kVA?
Sir, I don't know exactly, but I think so. The kilowatt is the unit of voltage in practical, right? I think so.
Kilovolt.
That's why I think so. That's
Okay.
why.
So answer is not correct. I will tell you.
Oh, thank you, sir.
So in a transformer, you have losses. Okay, there is iron losses and copper losses. So copper loss occur in wires due to the flow of the current. This copper loss occur when the transformer is under load. So these iron losses are constant losses. These losses are hysteresis losses, magnetic losses, eddy current losses. So these are all the losses not depends upon the power factor. Okay. So iron loss depends upon the current ampere. Remaining iron loss depends upon the voltage B, and copper loss depends upon the current A, ampere. So all the transformers are rated only in volt ampere or kilovolt ampere. Kilo means 1000. So all the transformers are rated in volt ampere or kilowatt ampere because the losses are not depends upon the power factor. If losses are depends upon the power factor, you have to multiply by power factor, then it becomes kilowatt. Watts are kilowatts. So if you buy a tube light, they will tell what wattage you require. If you buy a fan, they will ask what wattage required because all these equipments are depends upon the power factor. But transformer does not depend upon the power factor. So the transformers are rated in kVA. Okay. Understand? Jabesh Singh. Jabesh
Sir.
Singh. Do you know what is all day efficiency?
What, sir?
All day efficiency. All day. All day means throughout the day. All day efficiency. What is meant by all day efficiency? If he doesn't know, he'll tell I don't know. No problem.
I don't know.
Okay, I will tell you. So efficiency means we normally calculate in terms of output by input. So if we ask for any efficiency, so they will calculate the output, they will calculate the input and divide output by input. So all day efficiency means, so we look at a transformer in a distribution side. So it is working 24 hours. Okay. So it is working 24 hours. So all day efficiency means it is a efficiency of the transformer for 24 hours. All day means throughout the day. So in a distribution transformer, it works throughout the day, throughout the year. So we are taking for a single day. So it is known as all day efficiency of a transformer. So another important question. Naveen. Naveen G. Naveen G. Prasant.
Sir.
So there is a DC motor. Okay.
Sir.
Yeah, DC motor is there. Hello? Are you,
Sir.
can you hear me? I want to change the direction of the DC motor. It is working in
Sir.
clockwise direction. So I want to change it to anti-clockwise direction. What I have to do? I want to change the direction of the DC motor from clockwise to anti-clockwise direction. I put it in the chat box. I want to how to change direction of DC motor. How to change direction of DC motor. It is very important question. It is an interview question also. Naveen, tell me how to change the direction of the DC motor. Naveen, Prasad,
Sir.
tell me how to change the direction of the DC motor. You don't know? Okay, I will tell. So I am giving DC supply plus and minus to the DC motor. There are only two connections, plus and minus. In DC motor, there are two connections, plus and minus. So we are giving plus, so it will if we change the plus and minus to the two different wires, plus supply to minus supply and minus supply to plus supply means automatically the DC motor will change. So if you are writing in words, if you change the supply terminals, if you change the supply terminals, the direction of DC motor is reversed. Okay. If you change the supply terminals, the direction of the DC motor is reversed. So another question, Viswajit,
Yes, sir.
can you tell what is the function of the transformer oil? So in transformer you have oil. Do you know that? If you see a distribution transformer, so it has oil inside. Why it is there?
Sir, it is used to stop the voltage discharging.
Is due to voltage?
Discharging of voltage.
There is no discharge. It's the purpose of the oil. So the transfer of voltage is done through the coils, not through oils. Okay. So oil is used for a particular purpose. Mainly two purpose. One it is insulation, another one is cooling effect. So because in a distribution transformer you have a large voltage. So it is converting 440 voltage into 230 voltage. So it is a high voltage. So it will produce enormous heat in the coil. So in order to reduce the heat, we are using oil. So main purpose is cooling. So next purpose is insulation. The insulation between the primary and the secondary coil. So that is a function of the transformer oil. So I have asked very important questions. So you have to do it. Now I am going to a problem. So I am writing down the problem. So the question given is the speed is 1500, generated EMF is 125 volts. Speed is 1500 RPM. EG generated voltage is 125 volts. So next data is there are two questions. So first question is what is the field flux phi if it is reduced by 12% when speed is constant. When speed is constant, flux is reduced by 12%. What is Eg? Eg equal to what? Second case, now speed reduced to 1200 RPM. 1200 RPM. Speed is reduced to 1200 RPM. Flux is constant. Flux is constant. Now we have to find Eg. Eg equal to 1. So initially it is 1500 RPM. The voltage generated is 1125 volts. So first case, speed is remain constant. So it is in 1500 RPM. But flux is reduced by 12%. So flux is reduced by 12% reduced. So what is the Eg? Second case, speed is reduced, flux is constant. Okay. So they are not given about what is poles and so on. So they are a constant only. They're taking as a it is constant. So only thing is variable is flux and speed. How to solve this? So we know the formula in generator Eg equal to pi Zeton by 60 into P by E. So these are constant. P, A, Z, 50, everything is constant. The only thing is pi and n. So Eg1 equal to pi 1 n1. Okay. So 125 volts equal to pi 1 I doesn't know. So n1 is 1500. 1500. So you have to find what is pi 1. So pi 1 equal to 125 divided by 1000. So what is the value of pi 1? 125 divided by 1500 is 0.083 Weber. Okay. Now you have to go to the first case. So case 1. So Eg you have to find out. So you know doesn't know the Eg. I doesn't know the Eg. Eg2. But I know flux is reduced by 0.12%. So 12% means 0.88 by 1. So initially it is 100%. Now it is reduced by 12%. So remaining percent will be available. 0.88 by 1 into speed is constant 1500. Okay. So when you substitute pi 1 only, you can get the value. So I have to find out that pi 1 is 0.083. So 0.88 into 0.083 into 1500. So now you have to find what is the generated EMF. 0.8 into 1500. 0.083 into 0.88 into 1500. So the voltage is 109.6 volts. Okay. So what they have given is they have given the speed, they have given the generated EMF. So first question is flux is reduced by 12%. Flux is reduced by 12%. Speed is constant. So you have to find the Eg. Okay. So first I am writing the equation Eg equal to pi Zn by 60 into P by A, where P, A, Z, and 60 are constants. So I am using Eg1 equal to pi 1 n1. So I know Eg1, I know n1. So I am finding the pi 1, it is 0.083 Weber. Now case 2, first case I am taking, speed is constant, so I am using 1500. They are given 12% reduced, so I am using 0.88 by 1. So I already found out pi 1. I am substituting case, so I have find the generated EMF. First case I have finished. Second case. So if you are ready done, I will move to the next step. So if you write it down, I will move to the next step. So from the given data only you have to analyze how to change the formula and how to apply, and you can easily find the value. So if you are taking as it is, you can also divide EG1 by EG2, pi 1 by 0.8 by 1, pi 1 get cancelled. So you can also write it in a different manner. I will do it. Instead of finding pi 1 and higher circuit here, I am dividing this 1 by 1. So EG1 is 1500 pi 1. EG1 is 1500 pi 1. EG2 1500 into 0.88 pi 1. I am dividing EG1 by EG2 or EG2 by EG1. 1500 into 0.88, you have some value. Here 1500.1. So this get cancelled. Okay. So this EG1 will come here. Here it will be 15 into 88. 880, 440, 1320. 1320. This can cancel. So 132 by 150 into EG1, we know that it is 125. So you can cancel this. It is 110 volts. So if I find and found out it gave some error, some calculation error, 0.4 volts is gone out due to the fraction. It is actually 0.833333. So instead of doing this, you can do this. So initially it is 1500 pi 1. Now it is become 0.88 pi 1. So it becomes 1320 pi 1. So EG2 by EG1, so 1320 pi 1 by 13500 pi 1. Pi 1 get cancelled. Multiplying this, you get 110 volts. Here it is 109.6 because here it is 0.98333. Automatically it will change. So this fractional part is very important. So how many digits you are using? It is very important in the final answer. So I am taking 3 digits. I have leave a voltage of 0.4 volts. If I take 4 digits, it will be leaving 0.1 volts. If I take 5 digits, it is 109.99 volts. So how many digits you are taking is very important. So instead of doing this method, you go this method. It is better because it is we are accurately taking the answer. 110 volts. Second case. Second case also you have to do like this. So in this case, speed is reduced, but no need of changing the pipe. So here EG2 is 1200 pi. Pi 1, take it as pi 1. EG1 is 1500 pi 1. So EG2 equal to 1200 pi 1 by 1500 pi 1 into 125. Is cancelled. This becomes 4, 5. This becomes 25. So automatically it becomes a voltage of 100 volts. You can easily find these values easily. Only thing you should first write the equation, then you have to remove all the constant values outside and write the equation. EG1 equal to pi 1 N1. So whatever values you know, put it inside. 125 you know, pi 1 also you know, 1500 you know. Then EG2. So according to the data given, you have to change the formula. So here 12% reduced in flux. So I am using 0.88 by 1 into 1500. So EG2 by EG1 I can easily find it is 110 volts. Here the EG2 changes because speed changes, flux is constant. Pi 1 here also pi 1. So speed changes 1200, 1500. So multiply, you get a voltage of 100 volts. So the sum is over within a half page. It is a 6 mark or 5 mark question. So if you know the formula, you take the constant variable out, you take the variable alone, substitute the value EG1, similarly EG2, and you can easily find out. Similarly for the next case, EG2, and find out the voltage. So I will give another problem in machines. So if you have the right hand side, you tell me I have finished the right hand side completion. Then I go to the next problem. We completed the right hand side. So now I go to the next problem. Have we completed the right hand side? So 110 volts and 100 volts are the answer. EG1 equal to pi 1 N1. So N1 is 1500. So second case, Y1 is reduced by 12%. So it is a whole 100%. Now it is 88%. So 0.88 by 1. So multiply 8, you get 1320. So when you divide and multiply EG1, you will come here. So 125, you get 110 volts. So EG2 in this case, speed is reduced. So you multiply by this, by 1 get cancelled, you get a voltage of 1000 volts. Have we completed the problem? Shall I rub this? Rub. Okay. The question is, it is a 10 kilowatt DC generator, 10 kilowatt, 240 volt DC generator. This is a sun generator. Okay. It has a sun field, it has a armature. So, other data given is the armature circuit voltage drop is 10% of the terminal voltage. So, this IARA drop is 10% of terminal voltage. Terminal voltage. So, next data they have given is, so IARA drop they have given. Then they have given a sun field current of the rated 10% of load current. This current, ISH, ISH is 10% of rated load current. So this is the data they have given. Now, what they are asking is, so it is a 10 kilowatt motor, 240 volt generator. It has armature voltage drop 10% of terminal voltage, and wheel current 10% of rated load current. So you have to find the resistance of RA and RSH. So you have to find RA and RSH. So this is the question. So we see one by one. This is a 10 kilowatt motor. So V into I is 10 kilowatt. They are given the voltage also, 240 volt. So you can easily find the current. What is the load current? Okay. For ISH, they are given 10% of rated load current. From the rated load current, you can find 10% of the IL. So you can find the ISH. They are given the IRA drop voltage. So if you find ISH, you can find IE. IL minus ISH is IE. So if you find IA, you can find RE. Then IARA drop, this drop is equal to here this drop because both are parallel. IARA drop will be equal to ISH RSH drop. So you can easily find RSH also. This is a concept. We see step by step. Mirror ಆಗಿದೆ. Can I rub this? So if I rub this only, I can write it down. It is a simple problem only. So you have to do step by step. Then you can easily find all the values. So all the circuits are based on only circuit theory only. If you know circuit theory very well, all subjects are very easy related to electric or electronic circuits. So I am rubbing this. Hope you have written this. So from the power as well as terminal voltage, so I am finding the load current. So here it is 240 volt. The power is 10 kilowatt. So I am finding the load current IL is equal to power divided by terminal voltage. So 10 kilowatt is 10,000 divided by 240. Two 50 by 6, which is equal to 41.67 amps. Actually, it is 666 amps. So I am putting 41.67 amps. So find the load current. So they are given IARA drop is 10% of terminal voltage. Okay. So IARA drop is equal to 10% of terminal voltage. Terminal voltage is 240. 10% of 10% means 10 by 100 into 240 is equal to 24 volts. So I have found IARA. So ISH is equal to 10% of rated load current. 10% of rated load current. Rated load current is equal to 10 by 100 into 41.67 is equal to 4.167 amps. I write it down, 4.167 amps. So I have found ISH. From this, I can easily find IA. So after finding IA, I found RA, then I found RSH. So if you are written on the right hand side, put completed so that I can move to the next step. So these problems are easy only. You have to understand how it is going. What are the steps coming one by one? So from the total power, I have found the current, power by voltage. So from the sum, I have found the IRA drop and the ISH. Okay. Next, I have to find RSH as well as IA, finally RA. So I have to find RSH, IA, and RA. Three more steps are there. So you have written the right hand side. Okay. So IA is IL minus IA is 90% loss. Can you send me later? Here only all the current. does it know what is it? So ISH I know, IL I know, IE plus IL is 1.67, ISH is 1.45, which is equal to 763, 617, 45.4, 4 as approximately. So IA is 45.7. Because all the current are generated by the generator. It is cutting off steps. Current flow here. Current flow to the here we are finding IA. The all the finding IA. All the finding IA. We have to find IA. IA is 24 volts. And RA equal to 24 by IA is equal to 24 by 33.7. So we get some values. Similarly, ISH RSH is equal to 24. Because parallel circuits, so the ISH RSH is 24. The RSH is equal to 24 by 4.167 is equal to 4 volts. Point 5 to 4 ohms. RA is 0.5 to 4 ohms. And RSH is 4.167. 5.76 ohm. 5.76. So what I'm doing is first finding the load current from the power and the terminal voltage. So IRA drop they have given it is 10% of the terminal voltage. 10% of the terminal voltage. So 240 is the terminal voltage. You have to take 10%. It is 24 volts. Next ISH, it is 10% of the rated load current. For rated load current, I have found 48.67. So it is 4.167 amps. From the circuit, we can understand that all the currents are supplied by the generator armature. So it is coming to, it is only flowing through IL and as well as ISH. So IA got the IL plus ISH. Add this, get the IA. So IA RA is 24 volt. So you can find the RA. Since both are parallel, same voltage will be available. Same voltage will be here. So 24 divided by 4.167. Sorry, here there is a mistake. It is not 24. Here it is 240. Sorry, 240. 240. Why 76? So no. 57.6. 57.6. Because 240 volt will be available. 240 volt will be available. It is not 24. 24 is here only. 24 volt drop is here only. Here it is 240 volt. So 240 divided by current is 4.167. So voltage you know, current also know. So you have to find the RSH. It is 240 by 4.167. It is 57.6. I hope you have understand this. So this type of problem we will be asking in the so you have to follow this how to post waste.